Hi, I'm Elle. I'm a data scientist at Iterative, and I'm also part of a project called CML, or Continuous Machine Learning. CML is all about getting continuous integration into machine learning and data science projects. And now, if you're not familiar with it, continuous integration is an idea from DevOps that's all about connecting changes to your code to fast feedback, to testing how that's affected your ultimate project. And it's been really successful for a lot of teams, and we're excited to bring it into data science. Now, if you're not too familiar with continuous integration, I really think that the best way to start to understand it is not to read about it, but to see it in action. So the goal here is to kind of give you a sense for what it looks like in a sample project that's a pretty lightweight kind of machine learning project. And also to give you a bit of a hands-on walkthrough of what it looks like to use this tool in a fairly typical CI system, continuous integration system. So today we're going to be using GitHub and GitHub Actions, although everything I show you will also work in GitLab with fairly minimal modification. And I will also be providing all of the code that we use today, so you can follow along at home. So let's just jump into it. Let's go to my project repository. So I've created a repository called Wine, where I have a Kaggle data set for red wine properties and quality ratings. And that's just a CSV file here. And we're just going to be doing, a fairly conventional modeling problem where we have a lot of features about different wines, and we're trying to predict the ultimate quality rating that these wines are getting. Okay. So in this directory, I've also got a requirements file. So these are the packages that you would have to install using pip install in order for my software to train the model to run. And that training script is train.py. And so what I've got is loading in our data and doing a train test split. And then I'm fitting a random forest regressor. And then I'm going to report scores here. The score that we're interested in is R squared, so the proportion of variance in wine quality that's explained by our model. And I'm going to report the R squared for our training set and our test set, print them into a text file called metrics.txt. And I also create two plots. So the first plot is an estimate of relative feature importances in my random forest regressor. And the second plot is a plot of residuals. So how far are the true qualities of the various wines from their predicted quality ratings? So right now, GitHub is kind of acting as a file server. We've got all of our files here, and you could easily clone this repository into your local workspace, install the requirements, and then run the training script. But I'm going to show you how, through something called GitHub Actions, GitHub can actually do quite a lot of that itself. So we're going to be setting up a little continuous integration system so that every time something in this repository changes, you will automatically rebuild your model and reevaluate it. And so, when we've got a simple project like this, where there's not too many moving parts, that might not seem like such a big deal, but I can assure you that as you add complexity to the code and as you add team members, it really starts to matter. So let's create the key file here. To use GitHub Actions, you need to create a special file, and it's always in the same place. Create this directory .github./workflows, and then we're going to create a file called cml.yaml. And the file name itself is not important. It is important though that it be a YAML file. And let's go to the CML project repository to get a template. Yeah, I'm going to take a template here. And so what we're going to do is give our workflow a name, and I'm going to say model wine quality. We're specifying a trigger so that whenever our repository receives a push, that will set into action the workflow that we're going to specify. We're going to specify the kind of machine that the workflow should run on. So here we're picking the operating system. And we're also going to specify a Docker container. This is a Docker container that is part of the CML project, but you can use your own Docker container. You can also use no Docker container, but this is what's going to hold some of the CML functions that we'll be using as we go through the tutorial. And then this line here is pretty formulaic. You can basically always count on that being part of your actions workflow file. And this is just a detail for authenticating the repository and access. And now here's the interesting part. We're going to specify, okay, when we've received a push, what are we going to do? So we're going to pip install our requirements, and then we're going to run python train.py. And I'm going to add a little something. I'm going to say, let's print out what was in our metrics file just to the terminal. So I'm going to say echo model metrics. So I'm going to print that to terminal, and then I'm going to do cat metrics.text, and cat is just going to take the contents of metrics.text, put them into the terminal. Okay. And now let's commit, and I'm going to create a new branch. So one of the ideas that's often hand in hand with continuous integration is using Git flow. And the idea here is that whenever we want to experiment with adding something to our project, we're going to create a new branch in Git and have the development occur on that new branch. And then ultimately we can merge it into the main branch of our project, but we're going to treat the main branch as this is what's ready to go to production, and experiments or features are going to happen on new branches. So we're going to do git flow, and we're going to create a new branch. So we propose the new file, and we're going to open a pull request. We're immediately prompted to this page, and the pull request is kind of a place on GitHub where me and any teammates that I might have can all see, what is on this feature branch that we are considering merging into the main branch of the project. And you can see here that there is something running, and normally this doesn't happen if you commit in GitHub. It's because we just created that workflow file. So let's go look at details. And we're taken to this dashboard here where what we're looking at are the logs from a computer that is managed by GitHub. And we can see that this runner, it's called a runner, and it's just a computer managed by GitHub somewhere, is pulling our Docker container, it's running our action, it's running the workflow. We can see it installing all of the required libraries, and we just give it a minute. Okay, it looks like it wrapped up successfully. Okay, and if we go to CML run, we can see here that it printed out the text that we had asked for, printed model metrics, and then it gave some numbers. And this is okay, for a pull request. But it's not perfect. Ideally, when you make a decision about, is my model good enough for, to be my final model or to be the model that I send into production, it's not just enough to have that printout in the terminal about what are the metrics. We also want data viz. And in fact, in this case, we have images that are created by our python train.py script. So it would be great if we could view them and share them with anybody else who might be involved in decision making about this model. So we're going to go back to our project. I'm going to go onto the experiment branch. And we'll go to our workflow file, and I am going to add now some special CML functions. So the basic, what's happening under the hood with CML, or how it works, is that you're going to write whatever you want to a markdown file, a basic markdown document. And CML will help you write things like images to that markdown document, and it will help you return that markdown document to GitHub, and GitHub will display it as part of your pull request. And if it's not really clear what that means, that's okay. I think that as we show the example, I think that will become more clear. So let's just start by creating a markdown document. So instead of echoing model metrics into terminal, let's create report.md. And I'm just going to clean up this text a little bit. I think it'll look a little nicer if I do some formatting. And now instead of doing print the contents of the metrics.txt file into the terminal, let's append those to the report. Okay, and let's add some images. So the two images that were created by Python train.py are a residuals plot and a feature importance plot. So we'll do CML publish feature importance.png, and I'm giving it a flag to specify that we want this formatted for Markdown, and then we will append that to report.md, and let's do CML publish residuals.png, same flag. And I'm also going to give it a header. Let's do dataviz report.md. Okay, and the last step, we've got this report.md file, and let's deliver it with CML send comment report.md. Okay, that looks good. Now let's see what happens when we commit this. So we're going to commit to our experiment branch. And if we go to our pull request, we can see that whereas the last run has completed, we got the check mark, now we're running the workflow a second time. And so we kind of sit and we wait. And I'm going to drink this espresso. Okay, and it's completed. And now when I refresh the page, we're going to get a figure. So this is our CML report. As we asked for, we have our model metrics reported here, and we have our data viz. And so we've got this plot of feature importances, and this is informative in that it's telling us that a lot of the features aren't even being used yet. And we've got our residuals. So now I can choose, do I want to merge the project, merge my code as it is into the main branch of the project or not? And I have a hunch that we can do a better model. So let's go back to the code and let's get onto our experiment branch. And I'm going to go into my training file. And I have a hypothesis that because I've set the depth of my random forest regressor to be kind of shallow, it's not really able to learn about very many features, or it's not learning very many complex relationships. So I think that if we deepen, pick a larger depth, then we should get more interesting relationships between features, and hopefully we'll get better performance on the model. So I will commit this change and go back to the pull request, where we can see that yellow dot is telling us that we have a runner right now. This was the report from last time, and now we're waiting for our next report. So we'll just let it run. I will drink more espresso. And it's run. And now when we refresh the page, we're going to get a new report. Here it is. We can see that we have better performance on both our training and test set. And looking at those numbers, it doesn't look like we're overfitting. We do indeed have more features involved. And we can see that our residuals are looking quite a bit, they're better. They're clustered along the diagonal now, which is an improvement. And now we can decide if we want to merge this pull request. And so at this stage, if I had teammates here, then they might make a comment. They might be able, suggest something to do differently. They might approve it, but I don't. So let's just go ahead and merge. And let's say I made an amazing model. Okay, and now when we go back to the main branch of the project, we can see that our training script contains the change that we had made. And I think the really cool thing here is that, so not only now every time we changed our code, we got really fast feedback about what happened. And we got it in an aesthetically pleasing format, I think, that is easy for other people on the team to look at, easy to revisit. And if I go back to this pull request that I had closed, anytime I see a report, I can also go back to the commit that created that report. And when I go to this commit, I can actually look at all of the files that were here. I can browse the repository as it was at that point in time. And when I do that, I can see what were the requirements. I can see what was my workflow file. I can see all of this. I can see the code, I can see the data. And so basically I've now got links between my code, my data, my environment, my infrastructure for training, and the results. So I think that that's pretty powerful for kind of keeping all of those together. It means that you don't have, a graph that you generated who knows how long ago floating around in your local workspace. So this is the gist of using continuous integration with machine learning. This use case here is kind of among the more lightweight in that, all of our data fit in our GitHub repository. We didn't need any special hardware. So in the future, I'm going to be covering some use cases where maybe you can't fit your data set in a GitHub repository, or maybe the machine that GitHub Actions is providing you with to run your workflow is not powerful enough. We'll cover some of those scenarios. And I'm also very interested in, what scenarios in the projects that you work on could you see this fitting into? And if there's something that you think it's quite interesting, but you're not sure how to go about it, just reach out, let me know, and maybe we can create a use case around it. So thank you for watching. Please share any questions that you have, and we will try to get back to you as soon as we can. Thanks very much.